Hello kids. In this video, we want to learn again how to calculate a CIDR, right? CIDR. So we have this before in our school days, like 20 how many years ago? 18 years ago. Damn, that's so long. Yeah, but I already forgot how to do this. How to calculate CIDR. How many address does the CIDR block represent? You calculate, but where prefix is the number after the slash. For example, contains, and then here's a quick table that you can reference for the most CIDR blocks. 8 IP address. No man. How about here? Oh man. Okay. Classless inter-domain routing, or better known as CIDR, was invented in 1993 as the successor to the former classful network architecture. CIDR is a method for describing IP ranges primarily for use in allocating IP addresses, subnets, and for routing traffic on the internet. However, CIDRs are also used de facto everywhere else if you need to describe IP ranges, for example, in SPF records and firewalls and the like. A CIDR describes a range of IP addresses. CIDR ranges are always written as base IP address network prefix. For example, this one here. This is the base IP address. This is the network prefix. So for 0000/0, it's anywhere. And this one which refers to the range of average between this one until, yeah, this is one I want to calculate. This one here, 12 0 until this one here. 1 to 7, 10, 12, then 60, Y63. The base or start of the CIDR is this one is the start, and /26 is the network prefix, which describes how many IP addresses the CIDR includes. Okay, so how can /26 describe 64 addresses? It's actually super logical when you understand the background, but without understanding the background, it's just black magic. An IP address consists of four members. Example 127.10.12.0. Let's make this thing bigger. Alright, in reality, it's just 4 bytes, each with a byte between 0 and 255, that we write them as 127.10.12.0. Is only because it's easier to read and say out loud. Each of the 4 bytes consists of 8 bits. Therefore, an IP address consists of 4 bytes of 8 bits equals 32 bits. Okay, /26 of the CIDR then tells that this range describes the first 26 bits of the address. As long as bits 1 to 26 match in an IP address, it is part of the specified CIDR. The bit mask for 127.10.12.0 looks like this. First byte it's 128. So this one here. This is the byte. Second byte bits 9 to 16. So this one here is 10. Then third byte bits 17 to 24. So they're always 32. Okay, so this one here is 12. And 4 byte bits 25 to 32, 0. So these are all 0. Okay, as you might notice, the bit patterns are actually binary numbers. This one here in binary equals 1 to 7 in decimal. The prefix of /26 then means that it is the first 26 bits that describe the CIDR range. That is this one, this one, this one, and this one. As long as the IP address only varies in the last 6 bits, 32 minus 26 equals 6, and it is part of the current /26 CIDR range. I don't understand anything, to be honest. Okay. And here comes the kicker. Binary with 6 bits, you can have 64 different variations. Therefore, /26 can describe 64 addresses. I said there was a bit of black magic about it. Yeah, damn. 6 bits. 6 bits, you have 64 different variations. Really? Binary with 6 bits, you have 64. Yeah, so let us put that here, like in here, in this one, and then let us click this, and let's create a cider, right? Then readme.md, right? Cider. Okay, so 6. So 32 minus 26 is equal to 6. And it says that in binary, with 6 bits, you have 64 different variations. So this is 32 bits. Is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is 16. And then this is 32. Okay, and so for example, the 1 to 7, 0, the what's that again? 1 to 7, dot 10, dot 12, dot 0. So in binary, it will be like this. So this one is 1, 2, 3, 4, 5, 6, 7, 8. So that's it. And then what happens to the /26 first? /26 is equals to 32 minus 26 equals to 6. And this is 8-bit, and we want to 1, 2, 3, 1, 2, 3, 4, 4, 5, 6. Okay, so how many combination is this? So if you say 0, 0, 0, 0, 0, 1, oops, then 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 40, 50, no, 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 20, 40, 60. So that is 64 combination. So let's try to prove this. Really? I think no. I think it's more than. So I'm not sure what I'm doing right now. One, one, na, 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 na. Right, then 0, 1, 0, 1, 0, 1, 0, 0, 1, 0. It's so tiring, man. So this just ask how just ask ChatGPT. 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 Right, we're here. Let us ask how many combination is 6 bits in binary. Okay, so yeah, so this is a computation. A 6-bit binary number has 6 positions. So as we can see here, as we showed earlier, 6 bits have 6 positions. 1, 2, 3, 4, 5, 6. So that is the 6 positions. And each position can be either 1 or 0. The number of possible combinations for a 6-bit binary number can be calculated using the formula. Number of combinations is equals to 2, is it to the power? Is this the to the power of n? Or what is this? What is the called? The symbol and the context of it represents exponentiation. It indicates that the base number, in this case 2, is raised to the raised to the power of the exponent. In this case, and raised to the power. In other words, 2 one means 2 raised to the power of n. Yeah. Exponentiation is a mathematical operation. Damn. That's why you should listen to your class, kids. So here, 2 to the power of n. So we're in where n is the number of bits. In this case, n is equals to 6. Number of combinations is equals to 2 to the power of 6 is equals to 64. So therefore, there are 64 possible combinations for a 6-bit. Right, 2 to the power of 6. How do we calculate that? For the calculator. 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 Okay, how do we do that? 2 to the power. Where is the to the power? Is this one? 2 to the power of 6? No, that's that one. Uh, Calculator. How to do to the power of calculator. So E, right? So how to do that? Okay, calculator. Right, 2. So I'm using a scientific calculator in my iPad now. So 2 to the power, where's to the power? To the power of 6. 2, 2, 2. Alright, so I got it. So where's the calculator here? Do we have a calculator in Linux? Calculator, scientific or programming. Do we have 2 to the power? No. Of advanced scientific financial advance. There's no financials. Alright, so here, this one. So they say 2 to the power of 6 equals to 64. Yeah, so if you see somewhere like this, right? So if you have like this, then slash 26, that is 32 minus 26 equals 6. So 2 to the power of 6 is 64. So there will be 64 ranges. But how can this one and this one describe the same CIDR range? As mentioned above, what's this? How can the 26 and 10, 10, yeah, here, have the same range. As mentioned above, slash 26 means that only the first 26 bits are significant in the description of the range of IP addresses. If you look at the first 26 bits, then this one and this one are identical. What? Although the range can easily be written as 26, and that form of writing is also technically legal, and it's much more readable for humans to start with the first address in the range. This means that you can't just take a random IP number and then add slash 26 to say that the CIDR describes a range from and 64 addresses onwards. So what is subnet? with subnets, you can divide a network into smaller chunks. For example, if you have a network from this to this one, you can divide it into subnets with subnet address to 255.255.255.192. The network is split into four subnets of 64 addresses. When a device is assigned an IP address and a subnet address, the device automatically knows which network or which CIDR range it is part of and where it can route traffic locally on the subnet. Damn. Okay, so how do we apply that here? So, alright, so CIDR, IPv4 CIDR block info. How do we apply that here? So this is our CIDR slash 16. So it will be, so if that's the case, that would be 32 minus 16 is equals to how much? 16, right? So 16 and 2 to the power of 16 is equals to where's our calculator? Let's go to our calculator. Is this a calculator? Where's our calculator? Oh, no, here. Okay, so if we change that, 2 to the power of 16 is equals to, damn, there's so many. Like 2 to the power of 6, 64. 2 to the power of 16 is this one, right? So that is the range, and how do we do this again? Oh man, but how can, yeah, I'm sleepy now. I'm sleepy. So this one, or so this one, what's this? Specify your subnet's IP address block in CIDR format. For example, block size must be between /16 mask and /26 net mask and can be the same size as your, oh man, 17. Okay, here. Use the following procedure to create subnets for your virtual network cloud, a virtual private network. Depending on the connectivity that you need, you might also need to add gateways and route tables. You must specify an IPv4 CIDR block for the subnet from the range of the VPC. You can optionally specify a IPv6 CIDR block for a subnet if there is an IPv6 CIDR block associated with the VP6. For more information, see IP addressing your for your for your VPCs and subnets. If you create an IPv6 only subnet, be aware of the following. An EC2 instance launched in an IPv6 only subnet receives oh man, I'm so sleepy now. Alright, so let me go to sleep and then just continue this one later. Right? Agree? Do you agree to my plans? Alright, ciao. Ciao, everyone.